Hello viewers, welcome to another episode and integration. We are still on finding the area between curves. In the previous edition we did the area between a curve and the x-axis. Here we are going to treat the area between two curves, whereby you are given two functions. You are asked to find the area between those curves. So the steps involved is that first you will calculate the x coordinate of the 2 points of intersection of the two curves. So if you find the x coordinate, the intersection of the two curves, the x coordinate give you the limit of integration. It means you will not be given the limit of integration. Then two, you calculate the area under each of the curve separately. Then you find the difference between the areas bound between the two curves. So for example, let's say we have a question that we are able to have a curve, something like this, then the limit of integration from A to B. So it means this is the area that we are asked to find. So if the first y1 equals to a function of x, if you're asked to find the area bound between this curve and the x-axis, this is going to be your portion, where the limit of integration between A and B. Now, since the two curves are going to be on the same graph, so imagine I have the second curve from the origin, which also goes something like this, or let me take it from the point as this. So I have the limit still from A to B. So this will be the area that I will be asked. So our y2 will be equals to, let's say, a function of what? G of x. So you can see this could be a straight line, which is a curve upward, this one curve downward. You can see since they are going to be on the same graph, if I want to find the area enclosed by them, it means that if I transfer this diagram to this place, it will give us something in this sort. You can see it, that this is going to be the curve y1 equals to a function of x, and this particular one will be the function y2 equals to g of what? X. What are we finding? We are finding the area enclosed by the two curves, or the area bounded by the two curves. That if we take our mind into mensuration, we can see that if I am looking for this small space, which is the space above this, which is the space below this, I may not necessarily need the excess spaces here. So for me to be able to find it, I find the area of the whole object, then subtract the area of the below from it in order to have the empty space. What I mean is that we are going to find the area of the whole diagram, then we subtract the excess from it. Then you'll be left with the internal. So if you leave here as area of A, let's say, then this is going to be area of B, then this definitely will be the area of C. So if I want to find this area, it's going to be area, which is the C equals to the area of A minus the area of B. Still, the point of intersection will be A, since they are going to be on the same graph. But don't forget, finding the area here is on integration. So our area of the small portion enclosed by this curve and this curve is going to be, here will be the integral of what? y1, which is going to be, let me begin, a function of x. What will be the limit? The limit will be from A to b minus the integral of what? B, which is also going to be a function of g. What will be the limit of integration? Still from a to b. So finding the area of two curves, or area enclosed or bounded by two curves, is just finding the integration. They say calculate the area under each curve separately. Meaning I am finding the integration of this curve separately, finding the integration of this curve separately, then find the differences between the two. So the above curve minus the below curve will give me the space between. Do we get the point? It's going to be the curve above, the one that curve above. It can be a parabola that is going to be the U shape, opening down or opening up. This could be opening up, this could be opening down. The space between them is what we are going to find. And don't forget, in the earlier editions that we have, if I have the integration of sum or differences, you can see this is just showing the differences between two integrations. So this could also mean that integral from a to b of a function of x minus what? Function f of what? G of x. So I can maintain the integral from a to b and find the differences between the two curves or the two functions. Then when I am done, I will still have to use the same limit of integration or find it separately, which is also per the law of integration of sum and differences. Good. So now let's see. Find the area bounded between the curves y equals to 4x and y equals to 3x squared. What is our first step? The first step is that we find the point of intersection between the 2 points. Don't forget, if we have y equals to 4x and the same y equals to 3x squared, it means that if y equals d and y equals d, the two functions can also be equal. So that will also imply that 4x is equals to what? 3x squared. That's the meaning of y being the first point of call. So this will be eliminated. Now we can send this here or bring this one here. So I can have, let's say, okay, 3x squared minus 4x equals 0. If this travel to this side, it becomes minus, leaving what? 0. So what do we do? We factorize x. So I can have x as a factor, dividing this to give you what? 3x minus 4x divided by x will give you 4 equals 0. So as long as two terms are multiplied to give us 0, that means x is equal 0, which is this, or 3x minus 4 equals 0. And we know this will go to become 4 divided by what? 3. So x is equal 0 or x is equal 4 out of what? 3. We said first step, find the x coordinate, which becomes the limit of integration. So this is going to be our lower limit, this is going to be the upper limit. Second step is to what? Find the areas and the curve of each of them. And this time around, we are going to draw all the curves on the same graph. So let's see, I have my graph. Let's take the first one. We know this power of 1, meaning it's going to be a straight line. So if x is 0, intercept on the y-axis. If x is 0, y will be 0. So the first point is going to be here. If y is also 0, x will also be 0. So still the same point. So x being 1, y will be 4. 1, 4. If x is 2, y will be 8. You can see that it's going to be a straight line through this place. And that will be our y equals to 4x. let's come to this. Don't forget, this is a square, so we are going to have a parabola, and having a positive simply means that it will open up parabola, the one that hold water. So if x is being 0, y will still be 0, so you still pass through the origin. If y is 0, x will also be what? 0. So now let's take the values of x being increasing 1 to give it 3. 1, 3. If you have 2, which will be 4 times this, 12. So 2 will be 12. So the curve that we know will be passing through this place. And that will give us our y equals to 3x what? Squared. What are we looking for? We are looking for the area bounded here. That small space bounded between the two curves. Now the curves are going to move from the origin. So our lower limit is going to be 0. Then our upper limit will be 4 out of what? 3. So area, which we can find, is going to be integral of the upper from 0 to 4 out of 3, which is going to be 4x dx possible minus integral from the same 0 to 4 out of 3, 3x squared dx. So I can perform this integration, subtract, or I can put all together from 0 to 4 out of 3, 4x minus 3x to the power 2, all what? Dx. So that I use the same limit of integration. So what will I do? Increase the power by 2, by 1, that make it 2. So we divide by 2. So 4 divided by 2 will give us 2. So I'll be having 2x to the power what? 2. Then if I increase this by 1, it becomes 3. Dividing by the 3 will clear this 3. So we have minus x to the power what? 3. Is that a constant? No. So we take our limit of integration, 4 out of 3 and 0. Good. Putting in the upper limit, so it's going to be area equals to 2x, and your x is what? 4 out of 3 squared minus 4 out of 3 raised to the power 3 minus, don't forget, if I put in 0, I'll still get 0 throughout, but let's see. We have 2 0 squared minus 0 to the power 3, which we are going to ignore all of them because it will give us what? 0. So now let's maintain the 2. This is going to be 16 over 9 minus this will give us 64, and this will be 27. This cannot multiply this, but it can multiply the top. So that gives us 32 out of 9 minus 64 out of 27. So for us to be able to have the same denominators, we look for a factor of 9. A factor that we can multiply 9 to get this, and that will be 3. So 3 will multiply the top. 3 times this will be 96 out of 27, 64 out of 27. They have the same denominator. So now we subtract the numerators. That will be 32. So we have 32 out of what? 27. And that could give us, this will go there, I think 1. So 1.19 square unit. So when we come to this aspect, we can see the steps are not different from the area between a curve and that of what? the x-axis. Here, the spaces is between two curves. So the first, which is the upper, minus the down, using the same word, limit of integration. So I think the concept is clear, and the thin line has been drawn between the first episode that we did and this particular episode. If this concept is clear, share your thoughts with me in the comment section. Share this video with somebody who may need this on your friends list. Let them subscribe and get access to these educative videos. Thank you for watching. Bye bye.